This new lesson I call adaptive sound design. It's similar to what we did last time, but has a few exceptions. The last lesson that I called parameter-based sound design really kind of followed the idea of cause and effect. You hit a crate and you hear a sound. This new lesson can be thought of as state-based sound design. And it looks at what's happening with the state of affairs in this Unity game world and determines how fast am I driving the vehicle. Am I driving straight or am I turning it? And where am I in this world? And how does that position dictate what I'm going to hear when I pass objects that may be making sounds in this world? And all of those changes can be managed in FMOD and made to shift higher, lower, louder, softer, all of the above, based on the use of game parameters in FMOD. So in this lesson, we'll add some engine sounds to the vehicle. Even though there's not a water drain in the road that we're driving on, we'll add one because it makes a really good excuse to have an emitter that plays a sound that we would plausibly hear if we were driving a truck down a road. And we'll make some tweaks to all of those sounds to really help them sound realistic in the space. Let's go ahead and get started. So we begin in FMOD, and let's start with a new event for the truck engine. I'm going to right-click and choose New 2D Timeline. And by default, well, before that, let's go ahead and give this a name. Actually, rather than call this truck engine, I'm going to call this truck noises because it's going to make a couple different noises. And make sure that we assign this to the master bank. Just right-click, add to bank, browse master bank. There we go. That's assigned. Now, by default, of course, with every new event in FMOD, we get a timeline, bars and beats or time. But everything we're doing with this event is really based on parameters. So I can actually just remove this timeline sheet, and we are going to add a new parameter sheet. And oops, I already created this parameter because I have another version of this event in there just to kind of help me make sure I get all these details right. But you can choose new parameter, give the parameter the name RPM, set the range 0 to 1000, and then click OK. I already have mine in there, so I'm just going to add RPM parameter in there right now. And once that's in there, we will be able to add audio tracks with different sounds that we can change and modulate based on the RPMs of this vehicle. So let's go ahead and add some sounds. I'm going to add, well, before I add these sounds, I've already imported what I need. I'm going to add some additional audio tracks. And let's see, if I take a look at my temp, I've got idle and 2 engine sounds. Okay, yeah, there's that cheat sheet I was telling you about earlier. I put this together earlier and realized there is no way I'm going to remember all the details in a way that's really going to make this useful. I'm probably going to end up stammering throughout the entire tutorial, so let's just put some of this stuff in here so I can just cheat and look at what I've already done and then copy it as I go through this lesson with you. All right, so I've got a couple different tracks here in the RPM sheet for various engine sounds. Then, window, open up the audio bin, and like I said, I've already imported sounds that I know I want to use for this. I'm going to grab all of these diesel engine sounds. At least I think that's what I need. I need diesel, just 0 through 3. Okay, so diesel 0 through 3 I had a fourth one, but that didn't work out very well. And then I also want this tractor engine sound. So I'm going to take all of these. Let's just put these in there one by one, actually. I'm going to put the tractor sound down here on engine 2. I know it goes there. And then diesel 2, I'll put up here on the idle track. And then diesel 1, 2, and 3, I'll drop there on engine 1. Make sure that is how I want it. Yeah, 1, 0, 3, 2 is up there, tractor 2 is down there. Fantastic. Okay. So I'm going to go through and take care of some busy work, and while I do that, kind of talk about what's going on. First thing I'm going to do is set all of these so that they loop. I used freesound.org. I went through a bunch of different engine sounds, and I found that there were a couple diesel engine sounds that worked really well for this truck. They came from other trucks, either step trucks or semis. And then I also found that a tractor engine seemed to work really well for this too. So that's why we've got this tractor sound. You'll notice that all of these look like they're kind of short, and they are, because it's just a persistent sound of that engine running. But I worked on Audition. I made a loop so that when that sound plays, it is smooth. Sorry, also really loud. They're normalized, so we've got plenty of room to work with these. But you can hear we've got one tractor idling sound, or that's a diesel engine sound. Here's another one. Bit higher intensity. And so lots of different sounds in there to give us a good variety. And the thing that I noticed when I was working on this, well, I was using, as an example, let me open this up. This is the examples that comes with FMOD when you download it. And I really thought, after working on the go-kart tutorial that shows you how to do an FMOD and unit integration, that this ride-on lawnmower sound was really, really good. And if you go through this carefully and listen to these individual sounds and look at the way that's put together, it's really brilliant. And the thing that really impressed me about this is the fact that all these different lawnmower sounds are really similar. The engine is at a slightly different intensity, but mainly it's just has a different timbre. And I modeled this lesson that I'm presenting to you right now over this sound. Rather than use lawnmower sounds, I worked with the tractor and diesel engine sounds, but it's the same kind of idea. I wanted to go with sounds that had an interesting timbre, and then I'll show you how you can use different settings within FMOD to create change over time. So as the RPMs ramp up over the full range of this parameter, you'll hear that engine just start to rev harder and work harder as the vehicle speeds up, and it works really, really well. All right, obviously lots to do here. So I'm just going to, like I said, use this temporary one and break it down bit by bit. So I've got my first diesel sound here. In order to get this to mix right, I bumped the volume down to 10, and I added this little fade at the end. So let's do that. Minus 10 dB. Get a fade going right there, and I had that one go all the way out to 200. So let's do that same thing here. For your sounds, you may find that you need to create a different relationship, different mix settings, different everything. So while what I'm showing you will work for the sounds that I have, you may find that the exact settings need to be different for the unique sounds that you download. Now the next one that I'll work on is Tractor 2. Tractor 2 is probably the most basic because it's one that's just going to run continuously throughout the entire sound effect. You can see I've got that right there. It's at a lower level, so not doing much with the volume right now. But then we've got diesel 1, 0, and 3. And so we'll put those in. Diesel 1, which stretched out to about 400. And then this one was back at 300. And it stretched to, I think, about 700. Diesel 0 was 300 to 900. Okay. Oh, I forgot diesel 0. That's what's going on here. Did I even use diesel 2? 1, 0, 3, 2 is up there. 1, 0, 3, 2 is up there. There we go. All right, try to get this right. $300, $900, and that's at 600. Whoops, I've got these all mixed up. See, I knew there was a reason why I wanted to do this. And not try to recreate it from the ground up. Okay, I think diesel 1, diesel 0, diesel 3, and then we've got some crossfades here. This one's obviously a little shorter. This was another thing that I found to be really, really effective from that default FMOD tutorial with the lawnmower sounds. Was whoever designed that put together pretty intricate web of crossfades, but that's part of what allows the sound to be so smooth and so seamless. All right, this is looking right to me. A little bit more of a fade at the end of this one. Yeah, and I think we're good to go there. Okay, excellent. So let's listen to this. It's not going to sound great. It's just a lot of noise right now because we haven't introduced anything that changes this over time and allows the individual timbre of these things to really sing. So the first thing we're going to do, if I click on one of these, you'll see that there's, we don't have it on this one for idle, but we have it on diesel 1, diesel 0, and diesel 3. For each of those, you'll notice that there is this little modulator that's called auto pitch, and it's set to a different value. 400 there, 500 there, 300 here. And the way I thought about it is that when we hear this sound, as soon as it starts to transition, diesel 1 is going to go away, diesel 0 is going to take it over. And when auto pitch has a value of 300, it means that when this parameter value is here at 300, we'll hear this at the pitch that it was, that it's at its original pitch. But when parameter values are below it, the pitch is lower, and values that are higher, the pitch will also be higher. And so with that in mind, I wanted this to transition and have the auto pitch start to change in one direction or another at the point at which one sound was fading out and the other sound was fading in. And so that's roughly a pattern that I used throughout this. And I think it led to some good results. So here, we don't have auto pitch because I need to add it as a modulator. So you can right click here in pitch, choose add modulation, auto pitch, and that gives us this little modulator, and type in 300. And so what that means now, if I solo this, You can hear that pitch start to climb. And I have a feeling that could be completely overdriving my recording. So let's just back this down a bit. And sometimes it sounds kind of unnatural when you do that. That's why layering these sounds with so many others can be really, really helpful. And so there we start to get the beginning of the sound of the truck idling. Idling when the RPMs are low, and then the engine kicks in, it starts to work, and we hear something that sounds a little bit more like it is, well, doing what engines do. All right, let's move on to Diesel 0. Diesel 0, I set auto pitch at 500. Yeah, so it kind of gets to the middle more or less before when it reaches its original pitch, and then it starts to transition to the other sounds. So we'll do the same thing, right click, add modulation, auto pitch, and it's 500 is the default. That transition's a little awkward, but that's part of the reason why we have Engine 2 down here that can help smooth all of these and help them sound more solid as we hear them all together. All right, this one makes its transition at 400, and I wonder if I accidentally just kind of flip these around. Maybe. Let's see. 400, 500. Nope, that's where I wanted it to be. And we get a pretty smooth transition across the range. I gotta warn you, tweaking this can be a really slow process. In these lessons, I've talked about going into a wormhole. This is definitely one of those wormholes. The amount of time you can spend tweaking this is pretty extreme, but it's definitely well worth it too. I'm, to be honest, not completely thrilled with how this thing transitions right now, but when we add this second track in there, it will sound a whole lot better. But it's definitely well worth the time to tweak this and figure out which order of your individual files works best. It's a process of trial and error. Just do a lot of iteration until you get the result that leaves you feeling most satisfied with the finished sound effect. Let's see, what are we going to do down here with Tractor 2? I need to take a look at my cheat sheet and see what we're doing. Yes, that's what we have. Okay, I like the auto pitch idea, but I was really curious to see if I could do this in a way that was manual. And that's exactly what I did here. Rather than use modulation with auto pitch, I decided to use automation. And automating the pitch and saying that when this is almost at its full speed, I want it to be 7 steps above, and when it's down low, I set it to be 7 steps below. And now that we have that pitch set, is that doing exactly what I want? Yeah, that is doing exactly what I want. Okay. Now we'll have multiple sounds with lots of different layers of pitch changing. And that sounds much more like an actual truck. Adding this other track in there really, really helped make a big difference. And I was really pleased with the way that this pitch automation worked well. I thought initially it was going to sound unnatural, but it turned out really well. I'll say the one thing that I think helped make this work so well is the fact that this loop is very seamless. Motors tend to be pretty homogeneous, but you can get some peaks and valleys. I edited that track really, really carefully, and it paid off well for this technique. So if you want to try this, just make sure that you have a loop that's really, really smooth, and things should work out well. All right, what about mix? Where did I have the various levels of this set? Okay, this was at -10, and then I think, I did some volume automation here. But the idea that as this truck ramps up, I want it to kind of ease into this first diesel engine sound. So we can change that here as well. Set this back to -10 where I had it before. That's not that hard. And then double click to reset it to 0. Add automation to volume, and that was a -8. So I'll bring this down to -8. Bring that down all the way, and then set the curve so it ramps up and it happens pretty quickly. How does that sound? That's working well. I'm happy with that. I'm going to go ahead and save this in case the worst happens. So I think that is good for now. There's some further tweaking that we're going to do, but I think it makes more sense to do that when we're actually in Unity and we can hear how this sounds in context before we come back and tweak it. So let's leave that there for now. As you'll remember from earlier lessons, we drive the truck down the road. We have to turn the truck because we either want to avoid or hit the crates. And it would be good to add a sound that recognizes the fact that we're turning. So let's add another parameter sheet. This is another one that I already have in here, but you can choose new parameter. You can call it turn and set the range from 0 to 10. Click OK, and you'll have your parameter. I just need to re-up the one that I have. Yeah, and turn is from 0 to 10. The turning sound will have some squealing tires. And in order to give this independent control, we'll need to add another audio track. I'm going to name it tires, and then open up the audio bin and squeal loop. There we go. Drop my tire squealing loop in there. Make sure that instrument is set to loop. You can hear what this sounds like. Yeah, just some tire squealing. That one also edited to be a seamless loop. Tried to make it as homogeneous as I could. Because the way we'll do this is track in Unity the intensity of our turn, and then have this modulate between values of 0 to 10. And so we want that to become more apparent, louder. The sharper we turn, quiet if it's a softer turn. And the way I did that here in the original is to just simply have some volume automation where we don't hear that at all if we're not turning, but then we ramp up, and when our turn gets to the maximum value, we just go ahead and reset that to 0 with a soft curve. So we'll add automation to the volume of this, set value of 9 to be 0 dB, and then all the way down with a slight curve up, And if we solo this, you can hear how we kind of come in and out of that turn as that value changes. That is another one that's going to require some additional tweaking. But again, it's more helpful to see it in the game. And so we'll just come back to that and revisit it a little later on. So I think at this point, even though I wouldn't call any of these sound effects done, I am happy with where we're at. And so we can leave these in place and move on and create our storm drain sound effect. So we'll right click, choose new event. But this time, we're going to make this a 3D timeline. Or technically, I'm thinking about this being in the road. So yes, water is what goes down it, but it is a storm drain. So let's give it that name. And assign it to our master bank. And then I have another sound that was prepped and ready to go for this. Again, just take a dive into your favorite sound effects library. Search for something that sounds like water running down one of those drains on the side of the street. There we go, drain loop. And we'll drop that onto our timeline. You can hear what that sounds like. Makes sense. This is another one that I edited to be a seamless loop. And so I want to create a new loop region so that this can just play continuously. And as a 3D sound, this has on its master track FMOD's spatializer plugin. There is a lot to know about what's going on here, some of which I'll cover right now as we set this up. But if you look in the description below this video, you see I have a link for a tutorial on FMOD Studio 3D Panner by Stefan Schutz. Highly recommend that you watch that and listen to what Stefan has to say about the spatializer, its parameters, and how FMOD and the spatializer can interact with the Unity game in different ways in order to put your sound in the 3D world. In some ways, this is like the scatterer sound effect that we used in our last lesson, but it's different because it's coming from a single object. It's not spawning new instances of a sound, but it has that same ability to sound like it is in the world, and it can be as large or as small as you need it to be. Its parameters will change as you are far away or nearer to it. And there's a lot here. We'll set up some of those things now, but it's well worth checking out that additional lesson from Stefan in order to learn more and to see some of the drawings that he has, because I think it can help make some of these concepts a little bit more clear if just simply discussing them doesn't make sense right now. So we have our spatializer, and we're going to tweak some of these parameters. I'm going to keep this as our basic attenuation curve. And attenuation just simply means how the sound changes based on your listening position. So if something is making sound, we get closer to it, it's louder, but as we move away, how does that sound drop off or attenuate? That's what this curve will determine. And there's a bunch of different curves that we can use or things that you can customize. This default curve is really helpful for the kind of sound that we're designing for right now. We don't want a linear curve. We want it to have this subtle exponential shape. We don't want it to be as drastic as that curve, and we don't want to use this one. I believe these have names. I should know what they are, but I can't remember them off the top of my head. Because this curve, as this line will imply, means that the sound never entirely goes away. We do want the sound to go away when we're not close enough to it, so again, this default curve is great. Then we have min and max distance that we control with this little ribbon slider. And min distance is basically the distance to the object before it starts to attenuate. So how close can you be to the object and you will just hear it at its default volume. I'm going to go ahead and set that to be, wow, this is not going very well with the mouse. I'm just going to double click on the number and type it in, 2.0. But then distance, how far away can I go from this storm drain until I can't hear it any longer? I'm going to think about a night that I was out walking my dog the other day when there was snow that was melting and draining down into a drain. And I think a distance of about 15.5 seems about right. Again, this is another thing that takes some iteration in Unity in order to know if it's really working the way that we want it to. So that should be good for now. The other thing that you can tweak is envelopment. But you know what? Let's save that until after we've had a chance to hear this in Unity, and we'll come back and talk a bit about these envelopment settings. Right now we're going with auto, which is fine, but when you switch to user, you have the ability to customize some of these things, and that may be helpful for where we want to go. So we'll stick with auto for now. We'll come back and talk about envelopment a little bit later on. With those things in place, I can save, file, build, and this is now ready for Unity. So let's switch over and put these sound effects to work. So we're back in Unity, and after saving and building in FMOD, you can see the FMOD events tab is here, and storm drain and truck noises that we created earlier are here and available as FMOD events. Now we can assign these and hear them in this game world. Let's start with the storm drain. If you go up to your hierarchy and open up environment, if it's not open already, you'll see that there's an empty object containing road, and there's a bunch of different road sections that are in here. For whatever reason, they're not in order, but the one that's more or less in the middle is ground road 25. So I'm going to use that one. I get about halfway down this street. That's where I want to hear my storm drain. And once I've got that selected, it's over here in the inspector. I can just click to add a component. FMOD is already typed in there, but if you don't have that by default, just type FMOD and you get all the FMOD components. We want FMOD Studio Event Emitter. Event Emitter, that is not easy to say quickly. Play event, we want it to play when the object begins. We don't need to worry about stopping it, but we do need our event. Click the little magnifying glass, open up our events, double click on storm drain, and our event is there. And I am very pleased to say that that is all we need to do, because FMOD knows how we want this sound event to attenuate. As we drive closer to it, it will start to become audible. Let's just check that out. Of course, we don't have our engine sound in there yet. Yep, there we go. It's just really fun to do that. I'm driving by and it's on my left, so it's only in the left speaker. Pass it on the other side and it's in the other speaker. We can go around it, of course. And that's really all we need to do. It's in and it sounds good. Now, I guess now is as good a time as any to tweak some of these settings. So actually, let me put this back in play mode. Let me switch to FMOD. Live update is on. I had it on by default earlier. And let's change some of these envelopment settings. If I switch this to user, I can crank up the sound size. Oh, I thought we'd be able to hear it at that point. Well, oh, of course, I started the game again. I'm nowhere near it right now. Okay, so there I can hear it. Back up just a little bit. And then in FMOD, okay, we crank up the sound size, drive closer to it. And you hear how there's just a lot more of it when we get to that point. If we want to be able to hear it from farther away, we can increase the distance, of course. And so we hear it from, from much farther away. That's pretty self-explanatory. But if the sound size is gigantic like that, when the sound size is gigantic like that, it's we hear a lot of it, and it's really loud and really prominent. So thinking about what I discussed earlier, a distance of 15, sound size, I believe here in Unity, if we look at the obstacles, we can see our obstacles have a dimension, it's a cube, of course, of 1.55. So I imagine in this world that the drain is just slightly smaller. Let's just make it about half. So slightly smaller than the cube, 0.75, or you can even say a little larger and say that it's 1. And what that means is that with that attenuation, got to go backwards and find it. We should hear something that's more subtle this time around. Yeah, we pass it pretty quickly in the car. Let's go back to our road. I want to see exactly where that is in the world. Okay, yeah, you can see that it's right here. Oops, there we go. Yeah, I'm driving right past it. It's on my right. And you can hear it move all around you. This setting is called min extent. You can hear how it changes the directionality. Stefan talks about min extent in the video, and it's worth listening to his discussion of that because he talks about how it changes the directionality of something, which can be helpful in some cases, but if you do it too much, you can almost just kind of wipe out its sense of where it is in the world, which could be helpful for some things, but not something that you want to do in every single case. But I've got my sound size set here, and I think I'm actually going to go with something even smaller. I'm going to go with half. And I want to be able to hear this from farther away, so I'm going to bump those settings up. Save this. F7 to build. Come back here to Unity. And let's hear this. We've spoken about the wormhole before, and I am about to go in it. I want to try to avoid the wormhole at all costs, so save me from myself. I'm going to not continue to tweak that, but obviously there's a lot here that you can tweak in order to get all of this to work and to respond differently depending upon where you are in the game world. Speaking of which, really important concept that I kind of glossed over earlier. Well, we talked about the idea of being able to hear these sounds based on where they are in the world. Something that goes all the way back to our first lesson is the FMOD Studio Listener. This is the point of audition. All of these positional sounds that are using the 3D panner and the FMOD spatializer, all of them use the FMOD listener to determine where we are in the world and what direction that sound should be coming from so that it makes sense. So the fact that our listener is attached to the main camera, which is inside the vehicle, means that as we drive the vehicle around, we will always hear those sounds in relation to where we see ourselves, kind of suspended and slightly suspended behind and slightly above this pickup truck. So that's an important thing to keep in mind. And if for some reason you're dropping into this lesson and you haven't seen any of the earlier lessons and wondering why this works the way it does, it's because this FMOD listener is attached to our main camera, which is inside of the vehicle here in our hierarchy. All that really, really important in terms of understanding the point at which these settings are measured from. Okay, well, that's all good and well with that sound. Let's move on to our engine sound. That's going to be in our vehicle, and we can go ahead and click on Add Component, FMOD Studio Event Emitter, have it play right away, and attach the truck noises event. Fantastic. And just for due diligence, why is it not happy playing that sound? We're back, thank goodness. And we need to resume with coding this event. As the RPMs increase, we hear the engine start to work harder. But right now, when we run the game, we drive and it just stays the same the entire time. And it's doing that because we haven't made any changes to the code of this game in order to get an RPM value and send it from Unity to this FMOD event and allow that value to modulate this RPM parameter. So that's what our next step is going to be. We need to start here with our player controller script. If you've lost track of that or forget, go to the vehicle, easier here in the hierarchy. Vehicle is there, player controller script is accessible here, or it's here in your hierarchy, and you can just double click to open it. And it looks like this. Hasn't changed since our last lesson, but we're going to add some stuff in order to get this to behave and do what we want it to do. So the first thing is to create a new public float variable. Start with the value of 0, floating point number, we call it run RPM. This is where we're going to store calculated RPM values and then use it to apply that value to the emitter event in FMOD. Then we need to actually do the calculation. And that line is right here. In fact, I should put some comments into this code because that is what you do. RPM values, yes. And then we are going to calculate and store current RPM. And the reason why we're doing this is because we know that our vehicle velocity modulates between 0 and 10. We set our RPM value in FMOD to be 0 to 1,000, so all we simply need to do is just multiply the vehicle velocity by 100, and it gives us the same range that will align with the range of parameter values that we set in FMOD. Now that we have a variable and can store our calculations in it, we take this next chunk of code and apply that to our FMOD Studio event emitter. So we create an emitter object that we retrieve from the Studio event emitter that's attached to this game object. And then we simply apply RPM values. How did I end up with that twice? I don't know. We apply the RPM values to RPM parameter in FMOD. It's really that simple. So we'll save that, switch back to Unity, make sure that everything agrees. Yes, no errors. That's fantastic. And so now I should be able to drive the truck and hear the engine change. So we're at low RPMs and we hear it idling. We go faster and it ramps up. And you could probably hear how it sounds a little abrupt, a little harsh when we hit the crates. There's a way to smooth that out, and we'll take a look at that a little bit later. But before we do, there's another thing that we need to tweak in our code, and that is, in addition to RPMs and the changing engine sound, we also have in FMOD our turn parameter, where we're controlling the volume of this squealing tire loop over the same, well, not the same range, but over a range of 0 to 10. And in order to get this to be audible, we need to tell FMOD that we have a value for turn, and it should apply that value to this particular timeline. So back here in Visual Studio, I'm going to copy and paste another chunk of code, and then we can talk about exactly what's going on with that code. All right, yes, and what's it missing? It is somehow missing closing angle bracket, or curly bracket. There we go. All right, so what's happening here? Well, we have a conditional statement. And it's checking the input. Are we driving? And are we turning? In order for the turning sound to make sense, not only do we need to be turning, but we need to be going forward. Otherwise, if the car is sitting still, it doesn't make sense to hear squealing tires. So that's what this first conditional statement does. It checks to see if both the horizontal and the vertical input is engaged. Then, if that is the case, we have the same line of code that we saw earlier. Namely, we access our emitter, the one that we created earlier. We use the set parameter function, but this time we want to change our parameter turn. And I just noticed, and I'll show you to prove it, turn, this parameter, all uppercase, which means that I need to make sure that it is spelled correctly and all uppercase here as well. Fantastic. Okay, so here we set turn to 10.0 when we are turning. But this conditional statement right here, if we are not turning, then we're simply going to set that parameter to 0 so that we can't hear that squealing tire sound any longer. So let's save that, switch back to Unity, make sure that everything is okay. I don't think that's anything we need to be worried about. Fingers crossed. And we got squealing tires. Fantastic. Yeah, we have squealing tires. It's a little messy. The mix isn't great, but again, this is part of that iterative process that I talked about earlier. You know, we created our sound effects in isolation in FMOD. Now that we have them in Unity, we can tell, you know, the engine is way too loud. We need to back that down. The turning seems a little abrupt. We'll be able to hear that more clearly a little bit later on. But let's start to tweak some of these things and get them sounding a little bit better. So in fact, in order to do that, let's start with the engine, because that being loud just makes this whole thing really difficult to manage. We're here in FMOD, live update is on, and if we're here in the master track, now when we're idling like this, we really don't want the engine to be very loud. So down here, at like -23, that's kind of a comfortable place to be. But then when we're driving, we probably want to bring it up some. But remember, we want to be able to hear the squealing tires, which I'm not going to be able to get here. But also want to be able to hear the environment. You know, hear some wind, hear some of the birds. We can definitely hear the wind down here. So that gives me an idea of what I want to do. So let's stop Unity for just a second, switch back to FMOD, and let's make some tweaks here to the master fader. Let me right-click on this, choose Add Automation. Oh, and right now, I think because I'm doing this, it's actually going to automate it based on the turn. Yeah, this is on the turn sheet, and I don't want this to be automated because of turn. I want this to be automated due to our RPM values. So I need to be sure that I'm on that sheet, master track. Then we add some automation. Go ahead and add a curve here for RPM. And let's see, when the RPMs were down, I had it in the low 20s, so let's do that. And then when I get up to a reasonably good volume, or I'm sorry, RPMs, let's go with 200 or so. Let's try that level and create a little curve that ramps it up like that. So how's this going to sound? So this would be idling. And then as we take off, got a louder volume. I think that's going to work well. I like that. In fact, let's save that, F7, build it. Let's just hear that in context. Yeah, we can hear the idling, which is great. Wow, we can hear the turning more closely too. Now, all of you who are watching this are not driving this truck, and I think it probably matters that you're not only able to hear it, but you're also in control in order to recognize that the turning just seems too abrupt. It's just too much. And I stop turning and the turning sound just goes away instantly. Well, the reason that happens is because turning doesn't have anything to kind of smooth the parameter. We just set it to 10 or we set it to 0. There's no transition whatsoever. There's nothing that's going to smooth or modulate that value over a period of time. It's just going to jump from 10 to 0. We can change that here in FMOD though. If I select turn over here in the overview, you'll see that there is this parameter called seek speed. And seek speed allows you to set a rate by which you're going to change a parameter over time. And there's a couple different ways to do it. We can just set the rate here, and that will make it equal for both values going up and values going down. Or we can use asymmetrical, and that allows us to assign separate values for parameters moving in both directions. And I know from working on this earlier that asymmetrical really works better for turning. So a rate, an ascending rate of 47 and a descending rate of 23 works well for this. And what that means is that as I'm driving, all right, back after another weird technical glitch. Screen recording software is really doing some crazy things with audio levels, and as I'm sure you could hear, it was getting really distorted. But let's just keep moving ahead to finish this. We were last talking about the squealing tire sounds. We introduced some changes with seek speed to make those transitions smoother. And there's another thing that we can do here that I think will really help give this just a little extra nuance, and that is to make some adjustments to an equalizer that we attach to this track. So I'm going to insert a 3-band EQ here on our tires track. I'm going to use a gradual crossover, but I'm going to set that crossover value at 1.2 kilohertz, and then the high band gain is what I want to automate. And if I scroll here, I can see, yep, there we go. That's exactly where I want it to be. So I don't want this EQ to be working at all when I'm here closest to my highest level, kind of similar to what I'm doing with the volume. But I also don't want it to go away entirely. So I'm going to bring that down to about right there. -24 is where it landed. Let's push this curve up a bit and hear how that sounds. Yeah, maybe a little too much. Let's try -20. Yeah, I like the subtlety of that a lot. I think that works well, and it just kind of helps. Those high frequencies pop out a little bit more as the turn becomes more extreme. So I think that's the last of our tweaks that we can make right now. Save F7 to build and switch back here to Unity. Yeah, I'm really happy with that turning sound. You know, but I'm not happy with the abruptness of the RPMs. So let's switch back. We've got live update on, which is great. And here in RPMs, well, I can do the same thing that we did earlier with seek speed. And I can set a seek speed for the RPMs. Let's try a value that's like a little bit faster than a full second. And then switch back to Unity. Yeah. That allows those RPMs to move up and down a little bit more gradually. It's not quite as abrupt, which is great. And if I wanted to go even faster, okay, I just simply set a higher number. Yeah, I like how that's working. I also like to change some settings on my storm drain. So if I go to that storm drain event, I mentioned envelopment earlier and that there were a lot of things that we could tweak. Well, I'm going to go with a custom envelopment. First of all, I want to make sure that I have to be really close to this in order to hear it full. And I'm going to make the space just a little bit smaller. And I'm going to bump up the sound size to make it 1.0. Because again, I think we saw that the crates were 1.55, so this is smaller than the crate. And let me drive around and hear that. And if I just kind of park here off to the edge, I get a tiny bit of the storm drain, and I move closer to it, and it's clearly on my left, which is great. And if I wanted to exaggerate that and make it audible from farther away, well, we all know how that's done. But yeah, I think I like the smaller values overall. The wormhole goes on and on and on. It's so easy to just get lost tweaking this stuff. But the beauty is that we can tweak it. Yeah, speaking of which, all those adjustments I just made with live update on, I save it, F7 to build it, and now I know that those are committed to be a part of this project, and they'll be in Unity when I return and play through that again. But yes, the fact that we can tweak infinitely is both a blessing and a curse. Today it feels like a blessing because I can adjust all of the parameters that allow me to shape those sounds, whether it's in response to the position where I am in the game world or in response to what I do as a player, input keys that I press. I'm getting lots of changes that make driving the car seem more like actually driving a car, or make the sound of that storm drain more like passing a storm drain. And you can continue to tweak and refine these things to just get closer and closer and closer to simulating the acoustic effects and the sound properties that ideally suits your game world best.